Loud. Where we are going to start our time together is in section 1.1. Now, I know you don't have a book, so I'm going to give you all the stuff that you need to be able to be successful when you go through and do your homework. And like I said, as we're working examples, the way I work class is I like to work a problem, and then I like to have you work a problem or two. So if any questions arise while we're doing this, that's why we structure the class this way. Remember, questions are not an imposition. Questions are part of your learning process. Okay, so what we are going to start with in section 1.1 is solving linear equations. My guess is if you've taken algebra at any point in your past that you have seen this, there is probably absolutely nothing that is going to be mysterious in this section. So I like that. I like starting here because I want us all to be on something that we can at least know we've seen before, so we can all go up the elevator together from there. So my first thing is I want to ask you what the difference between two things is. So first, if I say this, 3x minus 7, and then over here I say something like 3x minus 7 is equal to, let's go, keep the numbers nice and relaxed, 14. One of those is an equation, and one of those is not an equation. Which one's the equation? The one on the left or the one on the right? Not a trick question. The one on the right. Yes, what makes the one on the right an equation? Perfect. Perfect. The equal sign makes this an equation. And so when you see an equation, okay, what you are going to be told to do more often than not, 99.9% of the time, when we have an equation, we solve equations. And what solving means is that I want to find the value that I can put right here that makes a true statement. Okay, makes both sides equal. Okay? So solving means I am finding the missing value to create a true statement. As we go through our semester, there's going to be several different types of equations that we solve. We're starting our lives here with linear equations. I'm going to tell you what a linear equation is in a minute. But before we go there, this thing, 3x minus 7, you will see stuff like this too. When there is no equal sign, this is called an expression. Now, there's lots of different things we might be asked to do with an expression. Usually, we're asked to manipulate it in some way. So you might be asked to evaluate an expression, meaning to plug a value in. You might be asked to do something like to factor or to simplify. I mean, there's a lot of things. I'm not going to sit here and list every single thing, but I'm just trying to give you some examples of the difference in instructions between an equation, which is what we're going to work with in this section, and expressions, which will pop up quite often as we go through our algebra. So far, so good. Anybody got a question, comment, or concern for me about where we are? Well, this equation right here, this 3x minus 7 is equal to 14. This is an equation, but more specifically, it's called a linear equation. The reason it's called a linear equation is that the power on the variable is 1. So a linear equation is 1, the power on the variable is 1. You have no variables on the denominators, you have no squares or cubes or anything. Your power on your variable is 1. And in fact, the general format, okay, I'm just letting you know this because I want you to be well prepared, even over prepared. The general form is a linear equation is anything that I'm just going to rewrite this, but instead of actually using numbers, I'm going to use letters just to represent they can be any numbers. Okay, so instead of a 3, I'm going to put an A, X plus B equals C, where X is the variable and A, B, and C are numbers. Okay, so all this has just been the amazing, fantastic introduction. Just hopefully you feel settled and like, okay, I've seen all this junk before. There's nothing here that's too big of a deal. I don't even have a question. I haven't raised my hand yet. So what we're going to do now is we're just going to get to the point where we feel comfortable solving different linear equations. And I'm going to take you back to the most basic linear equation because there's only 2 skills required to solve a linear equation. Once you have both of those skills, there is no linear equation that I can give you to confound you. Okay, so everybody got this? Everybody up to date with me? Can I erase? I'm trying not to go too far into the light because like I said, on my camera, I'm washed out, but I want you, if you need to be able to rewatch these things and get something out of it. Okay, then here goes. Here is the simplest linear equation that I can have you solve. Something like this. X plus 5 is equal to 19. Now I know most everyone in here can look at that. You can probably count on your fingers and you can figure out what the solution to this is. I totally get it. But I want to develop in you the skill to be able to do the appropriate steps so that when there's problems that have numbers that are not as easy to figure out or have more terms, you don't panic and you know what to do. Okay, so what my goal is, in case you don't know this, the goal in solving any linear equation is I got to get the X by itself. I want the X on one side, I want everything else on the other side. So what has to move if I'm going to get the X by itself? The 5 does, yes. What am I going to do? Anybody remember this from a previous algebra class? What am I going to do to get the 5 from the left side of the equation over to the right side of the equation? Why did you pick subtract? Perfect. You should be teaching the class. I'm not even needed here. Yes, we do the opposite. Okay, so this is a plus 5. So the opposite of adding 5 is subtracting 5. Now in this class, because this is our intermediate algebra, and my goal, because you are in the track that your next class is college algebra. Okay, if that's not true for you, maybe we should talk about it if you're in the right place. Okay, so I'm trying to develop the skills so that when you get to college algebra, that there's nothing going to mystify you. So for the time being, I would like you to write your steps. That's what I'm looking for. Okay, that helps me. That'll help you on the test because if you write your step and maybe you just have a little arithmetic mistake, but you know what to do for solving, I can give you partial credit. Okay, your test grade is going to be better. So I subtracted 5 from both sides. What happens to the 5s on the left? Cancel. I have X. 19 minus 5 is 14. Like I said, you probably already knew that. What 14 is called is the solution. If you remember, you look back on your notes, I told you when we solve a linear equation, we're looking for the value that when I plug it in makes a true statement. That value is called the solution. So if I put 14 in here, what's 14 plus 5? It makes 19. Yes, it does. And on the other side, we've got 19, and that would be a true statement. Okay, you can always check your answer. One other thing, this is a notational thing because I'm trying to help you, again, be successful. Our solution forms what's called a solution set. Linear equations usually have one solution, but there are other types of equations we'll solve that can have more. So what we're going to do is we're going to write our answer in some braces, okay, squigglies. These are not parentheses. These are not brackets. Okay, these are braces. That's important. Notation is very important. And you'll see if when we get to the beginning of section 1.5, we're going to do about the first third of it today. And then mainly we're going to talk about notation today. So far, so good? Okay, so humor me. I get it. This is, y'all are, you're bored already. But try this one. I just want to make sure we're on the same page. So X minus 11 is equal to -6. Solve that for me, please. I'm going to get started on this. If you're still working, keep working. Some of you are done. I just try to cut the middle between people who are already done and people who are still working, just to keep things progressing. If I'm going to get the x alone, what am I going to do this time? What's the opposite of subtracting 11? We're going to add 11, okay? It's the opposite. Okay, so it's the only thing I need to do here. So again, the 11s are going to cancel, and I get x. -6 plus 11 is 5. You can use a scientific calculator in here. I forgot to mention it when we're going over the syllabus. No phone calculators on tests, no graphing calculators. If you don't have a lot of money, I totally get it. I was in college and ate ramen with 2. I totally understand that. Dollar Tree is a very nice scientific calculator, and I love Dollar Tree because everything costs $1. Yes, thank you. Somebody's still awake. I love it. Okay, so x is 5. Here's my solution set. Boom, I'm done. All right, next problem. I told you there were 2 skills. That was skill number 1. You're halfway there. Here's skill number 2. We're going to solve this. We're going to do this one together. We're going to solve, let's say, 3x is equal to, let's keep the numbers relaxed, 18. Okay, this is the other skill. Again, you're probably bored out of your sleep because you've seen this 100,000 times in your life. But I just want to make sure. I got 3x. Now, in algebraic notation, what operation is going on between the 3 and the x? Because I don't see a symbol there. Multiplication, it's implied. Okay. So what's the reverse of multiplying by 3? How am I going to get the 3 from the left side of this over to the right? Yeah, exactly. So here's how I notate that. I'm dividing using a little fraction bar to indicate division. That's all a fraction bar means. I know fractions are super scary. We're going to talk about those later. So over here, 3 divided by 3 is 1. And when there's a 1 in front of your variable, you can write it. In this class, I won't be fussy if you do. Okay, if you write the 1, I'm not going to. So I got x is equal 18 divided by 3 is 6. There's my solution set. You can always be plugging back in to check, but I'm not going to take the time right now. Okay, here's one for you. And then we're going to go on and we're going to do problems that are a little more feisty. So let's try this. Let's say we have -2. I'm changing the variable just to be fun. -2y is equal to 24. Go ahead and solve that, please. All right, what did you do to both sides on this one? Divide by -2. Yes, I got a winner. Great. Yes, I gave this example intentionally because when we divide by the exact same thing. Okay, I erased it, but when we add and subtract, that's when we do the opposite. Okay, so I'm going to divide both sides by -2. The reason being, a negative divided by a negative always makes a +1. So I've got 1y here. 24 divided by -2. You can pop that into your scientific calculator and it tells you -12. And there is my solution set. Are we still okay? Okay, now what we're going to do is we're going to combine these 2 skills. The first skill was called the addition property of equality. What it means is if you add the same thing to both sides of an equation, it's still an equation. This is called we're dividing, but it's called the multiplication property of equality. Says the same thing. If you multiply or divide both sides of an equation by the same thing, you still have an equation. You haven't changed anything. Okay, so those are our 2 skills. Here's my next example. We're going to solve this one together. 2x plus 7 is equal to 25. All right. As I've said previously, solving means that I want to get the x by itself. So this is going to happen in steps for us. What is the first thing that I have to do before I can get the x by itself? I'm sorry, I just didn't hear. Masks. Somebody said it. Perfect. Before I can get the x by itself, I've got to get the x term by itself. So what I'm going to do is I'm going to get that stuff that's not part of the x term away. So we're going to subtract 7. So far, so good. Anybody got a question, comment, concern? Okay, so 7 minus 7, those cancel, and I've got 2x. Over here, 25 minus 7, I believe that's 18, but you should always check. I'm continuing on unless I see a hand. Well, now this is just what we did a moment ago. What's my last step? Divide by 2. Over here, 2 divided by 2, those cancel, leaves me 1x. Over here, 18 divided by 2 is 9. Boom, there's my solution set. Again, feel free to check. So you always know if you got these problems right or wrong, okay? You put the 9 here, 2 times 9 is 18, 18 plus 7 is 25. Woo, touchdown, there we go. Here's one for you. Please do this, 5x minus 4 is equal to 21. Solve that. What's step 1? Opposite of the -4 is to add 4. Again, the reason I'm starting there, if that's your question, if you're like, why did he do that? Why did he divide by 5 first? Because if I divide by 5, I have to divide every single term by 5, and now I'm going to start to have fractions, and we're trying to avoid those. I know we are. So I want to get the term that has the x in it alone first, and then we'll worry about the dividing. So I added 4, and I get that 5x. 4's cancel. 21 plus 4 is 25. And then I'm sure you're going to tell me that the last step here is always our last step is to divide. And I get that the x value that solved the original equation, the solution that would create a true statement is 5. We are now going to solve the hardest linear equation that I can possibly ask you to solve. Okay? Now you're trembling with fear. I totally get it. Here it is. We're going to do this one together. 8x plus 6 is equal to 5x minus 12. As far as the solving goes, there is nothing I can ask you to solve as far as a linear equation that is any more complicated than this. And what makes this complicated, quote unquote, is I've got x's on both sides, I've got numbers on both sides. And so my goal is I want to get all the x's on one side. I usually pick the left side because Miss Hilliard in the early 1990s, because I'm an ancient human being, demanded that we put the x's on the left. So it's just my habit. You can put the x's wherever you want. Okay, but I'm just letting you know I have the pen. The x's are going to go on the left. Okay, so we're going to put the x's on the left. We're going to put the numbers on the right. Okay, we're going to do this one step at a time because I don't want to lose anybody on this. Okay, so let's worry about the x's first. How am I going to get this 5x from the right side of the equation over to the left side of the equation? Perfect. Yes. Okay. Hopefully some of you were thinking that and you're just too shy because you think I'm going to laugh at you or something. I'm not. I love math. I love being here. I want you guys to learn. So what I'm going to do is I'm going to use that addition property of equality, and I'm going to get the x's all on the same side. So I subtract the 5x from both sides. And the reason why, on the right side, the 5x minus 5x, that's 0x, so just 0. On the left side, 8x minus 5x is 3x. I haven't done anything with the plus 6. I haven't done anything with the minus 12 yet. Okay, now we get the problem that we just did previously, okay, once we've taken care of the x's. So what's step 2 going to be? Subtract 6. So 6 minus 6 is 0, so that means 3x is on the left. Remember, we always keep our equal sign in the middle. Negative 12, negative 6 is negative 18. And then our last happy step is always the last step. I'm going to divide by whatever that is in front of the x. Negative 18 divided by 3 is negative 6. And boom, there it is. Here's one like that for you. Okay, this is the hardest equation that you can be asked to solve. So if you have any questions about this, good, ask them. If you don't, good, then you're ready to move on to the next thing. So your problem, very similar. It's 9x plus 1 is equal to 7x plus, I think, 8 is what I got written down here. minus 8. So again, I'm going to put my x's on the left. I just want to reiterate, if you're equivalent of Miss Hilliard when you had algebra, why don't you put your x's on the right? Okay, that's totally fine. We will end up with the exact same answer. Okay, same sign, same value. Okay, so if you got something different than what I get in your solution set, then we need to talk. Okay, so I'm going to put the x's on the left. How am I going to get the 7x from here over to here? That is exactly right. Subtract. So 9x minus 7x makes 2x. I haven't done anything with the plus 1. The equal sign stays where it is. And then I have a negative 8. Next thing I'm going to do is what? Yep, subtract that 1. The 1's cancel, and I've got negative 9. And then the last thing to do is divide by 2. I'm going to leave this as a fraction because I try to do as little work as possible. If you want to make this a decimal, if you grab the calculator and made it the negative 4.5, super duper. The only time I don't like decimals is when they're repeating decimals, and don't write an approximation. Okay, we always want the exact answer. So I'm just going to leave this negative 9 halves. Fractions are people too, so don't worry. Getting a fraction doesn't mean you did anything wrong, as long as you did your arithmetic right. We feeling okay so far? Okay, here's our next problem. So here's the next equation that we are going to solve, and it looks like this. I've got 4x minus 2x minus 5 equals 4 plus 6x plus 3. Let me give you a second to write that. Okay, so you might be thinking, well, hey, Berkster, now you've already lied to me because you said that the previous problem was the hardest, but this one looks bigger, so it must be harder. Okay, well, no. Okay, we've got some more terms here, but we don't have any extra stuff as far as solving is concerned. Now, we can make this look a little neater because we've got these extra terms, but we're going to turn this equation into this equation right here. So on the left side of this, how can I make this a little neater? What do I notice I have that I can take care of? Like terms, yes, an introductory algebra concept. Okay, so that's one of the things when you take the math readiness assessment. One of the things on the readiness assessment is, can you recognize and know what to do with like terms? And if you can't, then we need to talk. Okay, either I need to get you some extra help or we need to evaluate where you are, because I'm not going to talk about like terms any more than what I am right now. Okay, so the like terms I have are the 4x minus the 2x. So I'm going to combine those and get 2x. There's no like term with the negative 5, so I've got a minus 5 equals. You might be saying, hey, professor, there's like terms with the minus 5 on the other side. Well, they're on the other side. Okay, so the equal sign is our barrier. If we're going to move stuff, we have to do our opposite. Okay, so that's not just like terms. On the other side, what are my like terms? 4 and the 3. So I've got 6x. 4 plus 3 is 7. So I haven't done any solving. I've done some simplifying, is what that's called. But any equation you encounter in this section, once you've taken care of any simplifying, it will turn into something like this, which is the hardest equation that you can possibly be given to solve. So before I go on, I'm going to solve this pretty quickly in a moment. Does everyone understand, or does anyone not understand how we got from this step to this step? What's up? What part of that is confounding? Okay, so are you wondering why we didn't change signs, or are you wondering why we picked those things to combine? Okay, so like terms, okay, this is a great question. So if anyone else has the same question, it's beautiful. Like terms are things that have the exact same variable part. So both of these have an x to the first power. So I've got 4 of them, and then minus 2. Then we just do arithmetic. Okay, I've got 4 x's here, and then I'm taking away 2 x's. So if I had like x's written on little cards, and I showed you 4 x's, and then you took 2 of them away, you're left with 2 x's. Okay, that's why those are like terms, and that's how we could combine them. This -5 is not a like term. There's no x on it. Okay, so it doesn't go together with that right there. Same sort of thing over here. This 6x is not a like term with the 4 and the 3, because the 4 and the 3 don't have x's on them. Okay, so they are different things. But I can combine the 4 and the 3 since they both don't have x's. And that's just arithmetic. 4 plus 3 is 7. Okay, a little better? All right, from here on out, I'm just going to go ahead and finish solving this. I'm going to put my x's on the left. I'm going to put all my numbers on the right and divide. That's the pattern that we're going to get into here. So I'm going to subtract the 6x from both sides. 2x minus 6x. 2 minus 6 is -4x. I haven't done anything with the -5 yet. And there's my 7. All my x's are on the left. That's exactly what I wanted. Now I'm going to put all the numbers on the right. I'm going to move the 5. I'm doing the opposite with the 5. Instead of a -5, I add 5 to both sides. So the 5's cancel on the left. The only thing that remains on the left is the -4x. On the right, the 7 plus 5 makes 12. And then last but not least, this is always my last step. Divide by the -4. 12 divided by -4 is -3. And there's my solution set. Here's one for you. Plot away. Figure out what you can. Looks like this. 4x plus 8x plus 25. It's almost the same thing. Equals -9 plus 17x minus 1. And again, all you're being asked to do here is simplify this first by combining any like terms, and then you're going to solve what is the result. That breaks, I didn't do it. No, it's on. Oh, I just said that on camera. Yes, I did. I'm going to give you another 30 seconds or so. Make as much progress with this. Okay, so here goes. I'm gonna start solving this. If you have any questions, remember, please, that's why we're here. Otherwise, we wouldn't be getting together. So I'm gonna combine the like terms on the left and the right to make this look a little neater. So on the left, the 4x and the 8x, those are the like terms that I have. So I have 4 of them here, plus 8 more. 4 plus 8 is 12x's. I've not done anything with the plus 25. The 25 is not a like term. It does not have an x, so I cannot combine. I do not have 37 of anything here. Okay, so if you got 37x or 37 on the left-hand side, you've gone too far. On the right, the -9 and the -1, those are like terms. So when I add up -9 plus -1, that gives me -10. I don't have any like term with the 17x, so I left that the way it is. And then I have my -10. And now my pattern is I like to do the same thing every time. That way I feel nice and confident. And when I'm going into a test, I just do the same thing every time. So I'm going to put my x's on the left, I'm going to put my numbers on the right, and then I'm going to divide. So to get my x's on the left, I'm going to take the 17. I've got to bring it over here. And I'm going to do that by subtracting. 12 minus 17 is -5x. 17x is canceled. So now I've got all of the x's on the left. There's no other x term in this. Now what I'm going to do is I'm going to take the 25. I'm going to move the 25 over to the right. I'm going to do that by subtracting as well. 25's cancel. -10, -25 is -35. And at this point, I feel nice and relaxed because my final step is to divide by that -5, and I get x is equal to 7, and I'm going to write my solution set as the set with 7 in it. I'm going to write another example on the board. You're going to talk me through the first step, then you're going to do it. Okay, so there's not really much different. All we're going to do for the remainder of section 1.1 is I'm going to give you several more different examples of different equations you're going to see as you go through the homework and making your best attempt at solving them. Remember, if you get something wrong, don't beat yourself up. It doesn't mean anything bad about you. It just means that you're learning and we're trying to get some experience here. So here's the next one. I've got 5, then a parenthesis, x minus 4, then outside the parenthesis, a minus 12 is equal to 3 minus 2x. So I'll give you a moment to write that down, and then I have a question. So this problem has something a little novel. We haven't seen this yet, but again, it's one of those things I'm assuming you've seen before. If not, you're going to see it now. Before I can combine any like terms on this one, what do I need to do first? The parentheses. Does anyone remember what it's called when I get rid of the parentheses here? Is a property name. Starts with a D. Distributive property. Okay. Distributive property. So when I distribute, what am I going to do with the 5? 5 times the x. What does 5 times x give me? 5x. Perfect. Thank you very much. And then 5 times the -4. What does 5 times -4 give me? -20. Do I multiply the 5 times the -12 out here? Why not? You're shaking your head no. It's a beautiful answer. Woo! Great. Success. Okay, so go ahead and finish up that problem. Okay, the only new part to that problem was seeing the distributive property. The rest is for you. And so I'm going to collect these like terms on the left. I don't have any like terms on the right, so this one's even a little simpler than before. So the two terms on the left that are like terms are the -20 and the -12. Neither of those has an x associated with it. So I have 5x, -20, -12 is -32. And then I have 3 minus 2x. I'm going to put all my x's on the left. I'm going to put all my numbers on the right. So if I'm going to put all my x's on the left, that means this -2x has to be moved to the left. How am I going to move that -2x? Add it. Woohoo! That sounds great. 5x plus 2x, that's 7. I've canceled the 2x's over here. I'm going to move the 32 over to the right by adding it. We're always, in the addition property, we're always doing the opposite. Okay, so whatever the opposite of the sign is, we do that. So this started out as a -32, so I added 32 to get that to cancel. So I have 7x, the 32's cancel. 3 plus 32 is 35. Divide both sides by 7, and 35 divided by 7 is 5. So there is my solution set, the set with 5 in it. Here's another problem that involves distributing. I have a reason for asking this one. I want to make sure we understand how the distributive property works. So here's your problem. 2 minus 3, parentheses, 2 plus 6x equals 4, parentheses, x plus 1 plus 36 outside the parentheses. I added 32. It wasn't in your 32. Oh, put it over here. I had to add it, and that makes it positive 35. All right, I'm going to get started. Distributive property is the first thing. Now, I gave this problem on purpose. I did have an agenda with this because I just want to make sure that if you made the following mistake, that you know why you shouldn't have done that. Distributing represents the property of multiplication. If you are like a typical class, there's probably a couple people in here that saw this and said, oh, 2 minus 3 is -1. I mean, it seems reasonable. It's right there in front of you. But what operation did you just do when you did 2 minus 3? Subtraction, order of operations. Okay, this is why that is wrong. Okay, if you did that, okay, I'm not doing this. I don't want you to feel ashamed. I want you to learn. Okay, this is why that's wrong. Order of operations, which comes first, multiplying or subtracting? Multiplying in the order of operations always comes first. So if you subtracted here, okay, erase, okay, and make a little note to yourself that multiplying comes first. Okay, so I'm going to do the distributive property. So this 2 right here is just going to stay. It's kind of bored right now. So then I have -3 times 2 is -6. Then I have -3 times 6x is -18x. On the other side, just because of the way it's written, we don't encounter the same sort of issue. So I have 4 times x is 4x, and 4 times 1 is 4, and then plus 36. And now it just becomes another example of the problems we've been doing. I'm going to collect my like terms. I'm going to put my x's on the left, numbers on the right, divide. Okay, so hopefully you're seeing Once you get used to it, you're doing the same exact thing, just with different numbers on every problem. Collecting those like terms. The 2 and the -6, both of these do not have x's, so 2 minus 6 is -4. And then the 4 and the 36 both don't have x's, so that is 40. X's on the left, numbers on the right. So x is on the left, I'm going to bring the 4x to the left. I'm going to subtract it because it's presently a positive 4x. So the opposite is to make it negative. And I have -18 minus 4, that's -22. X is on the left, the numbers are going to go to the right, so +4. And I have -22x, 40 plus 4 is 44. And last but not least, I can exhale because we've gotten to the end, and 44 divided by -22 is -2. And that's my solution set, -2. I've got one more problem for each of us, and then just a couple more terms that are associated with solving linear equations. And then we'll be done with this first section. So if you got a question, I see a couple people looking at this problem, giving it odd looks. Maybe you have a question. Don't be shy or bashful. There's no reason to be, okay? We're all on the same team here. Okay, I've got one more for me. I've got one more for you, okay, of what you're going to see as far as solving equations. So here is the one more for me. And it goes like this. I've got x plus 7 over 6. Uh-oh, heart rates are going up all over the classroom. 2x minus 8 over 2 is equal to -4. Okay. I am guessing that you see these fractions and it's causing a little bit of anxiety because most of my students do not relish being approached with fractions. So what we're going to do that's going to help us, and this will come back a couple different times this semester, is we're going to practice fraction avoidance. Okay, if you're a psychology fan, we are going to practice avoidance. What we are going to do is we are going to clear the fractions. Meaning what I want in my next step is I want to have an equation that does not have any fractions in it. Okay, that I want to avoid them. I want to pretend they don't exist. The process for doing that, and again, we're going to use this 2 or 3 more times over the semester, so good to learn it and get comfortable with it now. The way we're going to clear the fractions is we are going to multiply every, and I'm going to underline the word every, it's important. We're going to multiply every term by the lowest common denominator. I'll share with you a little math secret. You can use any common denominator, okay, and it'll work. Okay, so don't worry if when you're looking at this and you're predicting what the common denominator is going to be. If you've got a different common denominator, it'll be okay. Your numbers will just be larger than mine, okay, but don't freak out. But I know that sometimes we come in here, we don't remember how to find a common denominator. I don't have a lot of time to teach you about that. If that's something that you struggle at, I have some videos, okay, so from some other classes I've taught doing that. But here is a technique to find a common denominator that will always work. So for instance, okay, here's an example. Let's say I want to find the common denominator between, let's go 1/4 and, I don't know, just 2/3, doesn't matter. Now, if you have numbers that don't share any factors, you can always just multiply. 4 times 3 is 12. Boom, there's the lowest common denominator. But that doesn't always work, because if you have things that share factors, you'll end up with something larger. So here is a method that I teach in my introductory algebra class. It's called the listing method. Okay, so if you don't have a method to find the common denominator, that will always work. The listing method will always work. Sometimes it's a little bulky if the numbers are large, but it'll get you there. And for the listing method, what you do is you just take each denominator. So 4, I'm going to put a colon, 3, I'm going to put a colon, and I'm just going to list the multiples. So what it means is I'm going to start with 4, and I'm going to do 4 times 1, and then 4 times 2, and then 4 times 3. These are called multiples. 4 times 4, I'm just going to list some of them. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and you can always add more to the end of the list, but I get bored easily, so I'm going to stop there. And now I'm going to do the same thing for 3, and then I'm going to stop when I get to the first one they have in common. That will be the lowest common multiple. Okay, the lowest means the smallest, common means what they have in common, multiple. So here we go. 3 times 3 is 1, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Oh, that looks familiar. Woohoo! 12 is the first one that appears in both lists. Now, we can do the same thing for 6 and for 2, but I thought that this was a little easier pair of numbers than 3 and 4. That's why I changed them. What's the common multiple between, or the lowest common multiple between 6 and 2? 6. Yeah, if you do the listing method, you're going to come up with 6. Somebody in here said 12. Or thought 12. 6 times 2 is 12. You can use 12. Okay, it will work. But your numbers are just going to be larger, and I like to use small numbers because I don't like to tax my brain. So I'm going to multiply every term. I've got 3 terms here. Terms are what the big things separated by my plus and minus signs. I'm going to multiply every term by 6. So I'm going to multiply here. I'm going to put it 6 over 1, just so I know where the 6 goes. And then here I'm going to squeeze this in, 6 over 1. And then out here, I know this is not a fraction, and so our temptation is to forget about this last term, but I got to multiply by 6 out there, otherwise I've changed the problem. Everything gets multiplied by 6. Are you tracking with me? I'm trying to create something here that you can replicate, okay? Because I know we don't love fractions. My next step should have no fractions if I have done this properly. So here goes. I've got 6 times x plus 7 over 6. What happens to the 6's there? They're going to cancel. I got a 6 in the numerator. I got a 6 in the denominator, right? So what's 6 divided by 6? You throw that in your calculator. 6 divided by 6 becomes 36. Math heart attack. Math heart attack. 6 divided by 6. 6 divided by 6 is 1. Okay? So that's why they cancel. When you divide them, it becomes 1. So I'm just left with x plus 7. Okay, try again. Redemption here. Second term, I've got 6 times 2x minus 8 over 2. What happens between the 6 and the 2? What's 6 divided by 2? I know you know. I'm not ignoring you. Just letting everybody else catch up. 6 divided by 2 is 3. Yes, another person. 2 people. Woohoo! 6 divided by 2 is 3. Any suggestions on what I should do with this 3 and the 2x minus 8 that's already there? We've already used the word in this class today. Distribute. Yes. So I'm going to distribute. I'm going to put a little note here, just so that when you're looking at your notes later, you know what I did with this. Okay, so 3 times 2x is 6x. 3 times negative 8 is negative 24. Now the other side, negative 4 times 6 is negative 24. No more fractions. It becomes a problem just like we've done a dozen of already. So I'm going to collect my like terms. X plus 6x is 7x. 7 minus 24 is negative 14. Yes? No? That's not right. Negative 17. That's better. a long weekend. All of my x's are already on the left. I don't have any x's over there on the right, so I've saved myself a step. So I'm going to put all my other numbers. I'm going to add 17 to both sides. Negative 17 plus 17, those cancel. Negative 24 plus 17 is negative 7. And then, sigh of relief, I finally made it to the end of this problem. And I end up with negative 1, and there's my solution set. So here's a clear the fractions problem for you. Same thing, almost same numbers. Okay, I'm not trying to confuse you here. I'm just trying to give you the opportunity to write this stuff out and sort through it and struggle through it, because that's how you're going to learn it. So that when I put it on the test, because when I make my test, I forgot to mention this at the syllabus, I'm not super clever when I make my test. If you're wondering, why do I need to do the homework? Because when I make the test, I just take homework problems and I change numbers and I put them on a piece of paper for you to do. Okay, it's not going to be that intense if you've done the homework. So keep up, please. Here's your problem. Looks like this. X minus 4 over 4 plus 2x plus 4 over 8 is equal to 5. Just to give everybody a nudge, what's the common denominator, or the lowest common denominator of these right here? 8. Okay, so multiply by 8. If you use 32, it'll work. If you use 24, it'll work. Keep going. But the lowest common denominator is 8. I'm just going to start clearing fractions here. Told me the common denominator was 8, or if you use 16 or 24, 32, all those will work. Your numbers will just be different, but we will end up with the exact same answer. So on the first term, 8 divided by 4 leaves me 2. Again, I'm just going to make a little note. I'm going to take that 2 that's left over, I'm going to distribute. So 2 times x is 2x. 2 times negative 4 is negative 8. Over here, the 8s both cancel. That's great news. That keeps things even simpler. So I'm left with the 2x plus 4. On the other side, 5 times 8 is 40. I just thought of a question while you guys were working the problem. We defined the common denominator as 8. Why didn't I use the 5 when I was figuring out the common denominator? Maybe somebody did that. Is the 5 in the denominator? No, 5 is 5. 5 is 5 over 1. Okay, so if it was 1/5, okay, the 5 would be in the denominator, and we would have taken that into account, used the listing method. Okay, so that's why, in case that was your question on your mind, I don't want to leave anything unaddressed. So collecting like terms, I've got two x's here. I've got two more x's. That's 4 of them. I've got -8 plus 4. Your calculator will tell you that that is -4 is equal to 40. I'm going to add 4 to both sides. And I get 4x is equal to 40 plus 4, or 44. And then divide, always the last step. And 44 divided by 4 is 11. And there's my solution set, the set with 11 in it. Just two more little things to mop up, and then we're done with this first section. Then I'm going to call the roll, and then we'll see what time it is at that point. Every equation we have solved today so far is called a conditional equation. The term for every equation we solved has been a conditional equation, because what we have just found is the condition under which the equation is true. This equation up here is not true for any value of x that I could possibly pick. It is only true under one condition, and that condition is if x is 11. Okay, that's why it's called a conditional equation. But there are two other terms for equations that you're going to see. And I'm just going to give a super simple example of each. The first one is this. Let's say that I have 2 in parentheses, x plus 4 is equal to 2x minus 5. I'll give you a moment to write that down. So you're going to encounter something like that on your homework. I know you are. I've seen the homework. And it starts out innocently enough. You've seen equations, so no big deal. I'm going to distribute like we've already done. So sure, 2 times x is 2x. 2 times 4 is plus 8. Well, until you've done a few of these, you might not know that anything is coming up. So I'm going to do the thing that we've been doing the whole time. I'm going to put my x's on the left and my numbers on the right. So here I go. I'm going to put my x's on the left. That means I got to take the 2x. The 2x is going to go onto the left. How am I going to get the 2x from here over to the left? Subtract. Same answer to the same question I've asked 52 times. I know it's a boring question. I get it. But here's something new. What happens to both sides of the equation when I subtract the 2x and bring it to the left? Yeah, exactly. The 2x minus 2x, it cancels over here. The 2x minus 2x, it cancels over here. So I've unintentionally canceled the x's on both sides. So I'm just going to bring down what I have. I've got an 8 on the left. I've got a -5 on the right. So we're going to pause and we're going to think, does this? Well, 8, this is a statement. There's no variable in it anymore, okay, to change anything. 8 equals -5. Is that a true statement or a false statement? That's false. 8 is not equal to, if 8 is equal to -5, then I'm going to take my -$5 and you're going to give me $8. Okay, we can do that exchange after class. Okay, so 8 is not equal to -5. This is a false statement. What this is called is a contradiction. In a contradiction, what that's telling you is that there was no value of x. Okay, so if you want to make a note, I'm not going to write this down, but if you want to make a note about what a contradiction is, it's saying there is no value of x that would make a true statement. There's no value of x that makes both sides equal. So the solution for a contradiction is that there is no solution. And since we're writing everything as a set, we're going to write the empty set. For the empty set, I use a pair of squigglies with nothing in between them. That's empty. Some of you have had math teachers, though, who have used the null symbol for the empty set, which is totally fine. The null symbol is like an olive with a toothpick all the way through. Don't combine the symbols. Pick your favorite one, either the squigglies with nothing in them or the null, and go with it. Okay, because if you use both, you no longer have an empty set. Okay, you have a set with something in it. It's a technicality. I majored in set theory, so I get drunk. Okay, here's the other thing. You're almost done. You almost made it to the first day. Good job. Okay. I'm gonna even make this simpler than before. So let's say we did something and we worked our algebra magic on an equation and we come up with something like this. 3x plus 7 equals 3x plus 7. Now that looks suspicious, but I don't know what it means, so I'm going to keep doing what Mr. Perkins has told me to do the whole time. All of my x's on the left. So to get the 3x from the right, to move it over to the left, I know you're thinking it. I'm not even going to ask the boring question. I'm going to subtract it. And just like the last problem, when I subtract the 3x from both sides, it cancels on both sides. But this time, something different is the result. On the left side of this, I've got 7. On the right side of this, I've got 7. This time, is this a true statement or is this a false statement? Is 7 equal to 7? Yeah, always, right? There's no variables. That's never going to be false. So this is always true. What this kind of equation is called? It's called an identity. If you want to summarize what an identity is, you might say this: an identity is an equation, and it does not matter what value you pick for x; it will always work. Any value of x always will work. Okay, so if any value of x will always work, what that means is all real numbers are the solution. And this is where we will pick up on Wednesday, is I need to teach you algebraically how to write all real numbers. Okay, but for now, when you're doing your homework in my math lab, I think it's just going to give you a little selection that if the answer to this is all real numbers, you're going to select that choice. Okay, but we will learn that on Wednesday. Don't pack up yet. I know it breaks my heart, but you're excited to go. Let me shut down the recording. I need to